Here we have a square PQRS with sides of measure 8 centimeters. What we need to find is the area of this triangle PQO. Now you can see that there is a diagonal PR. Now my question is, if I extend this QO, will I get a diagonal? The answer is no. Why is that? If you consider any square, what do you know about it? All the four angles are 90 degrees and each diagonal acts as an angle bisector, or in other words, it cuts the angle into two equal parts, or in other words, the angle that the diagonal makes with the adjacent side should just be 45 degrees. But you see the angle that it is making here, it is 60. So there is no way that we are going to extend this and get a diagonal. So what will we do? We will construct the diagonal ourselves. Let us join QS and let us get another diagonal. Now tell me, what else do you know about the diagonals of a square? If the square is of side A units, then its diagonal will be of the measure A root 2 units. And moreover, the two diagonals will bisect perpendicularly. That means they make right angles with each other at their point of contact. Suppose here also we have two diagonals, right? Let their point of contact be A. Then what you have here is a right angle. What else? They bisect each other. That means they cut each other into equal parts. Now, how does this information help us? The square that we are dealing with, which is PQRS, its sides are of measure 8 centimeters. That means its diagonal, both of its diagonals will be of measure 8 root 2 centimeters. And what else do we know? These two diagonals bisect each other perpendicularly, which means this whole diagonal PR is of length 8 root 2. But each of this, at the point of intersection of the diagonals, it is cut into two equal parts, which means here you have a 4 root 2. Here also you have a 4 root 2 centimeters. So there we have got rid of all the unnecessary markings. What do we have? A triangle PQO. We need to find its area. Now what is the area of any triangle? It is half into base into altitude. What is this base and altitude that we are talking about? The base is any side of the triangle. Here, for example, let me take PO. It is any side of the triangle, and the altitude is a perpendicular line from the opposite vertex to that base. Do we have such a line? Do we have a perpendicular line which connects OP to its opposite vertex Q? Do we have that? Here, QA. QA is the altitude that we are talking about. Now what is OP? OP is 4 root 2 plus OA. And then what is QA? We have found that to be 4 root 2. Now all we need to do is find OA. So how do we find the length of this line segment OA? Consider the triangle OQA. Now tan 15 is opposite side by adjacent side, which is OA, which is what we want to know. OA by 4 root 2, or in other words, we have OA is equal to 4 root 2 into tan 15. How will you find tan 15? What is 15? It is 45 minus 30. And what is tan A minus tan B? Now we apply this formula, tan A minus B formula. Then what is the answer that we get? Tan 45 is 1. Tan 30 is 1 by root 3. Now you apply the formula. What you get is root 3 minus 1 by root 3 plus 1. In these cases, it is always better to rationalize the denominator. So here you will get so there our tan 15, when we apply this formula, we get that our tan 15 is 2 minus root 3. Now we have got tan 15, and using that we can find what OA is, but that is not what we need. We need the whole of OP. Now what is that? You apply the value of OA here, and you get OP is what? It is 4 root 2 into 3 minus root 3. Now this is the length of your base, and what is the length of your altitude? It is 4 root 2. And what is the area of a triangle? It is half into base into altitude, which means what? 16 into 3 minus root 3 centimeters square is the answer that we are looking for. That is all for today. Assalamu alaikum.